Hello there and welcome to A2 Maths. We're on Specimen Paper 2 and here we're looking at question 3, a rates of change question. So a cup of hot tea was placed on a table, lovely. Time t minutes after the cup was placed on the table, the temperature of the tea in the cup in theta degrees Celsius is modelled by the equation of theta equals 25 plus a e to the minus 0.03 t, where A is a constant. The temperature of the cup of tea was 75 degrees Celsius when the cup was placed on the table. Find a complete equation for the model. I think what they're trying to get at here in part A is that they want us to work out the value of capital A. So when the cup was placed on the table, or in other words when T is equal to 0, the temperature theta, they use theta because theta is actually the Greek letter T, so they use theta here for T for temperature, was 75 degrees Celsius. So what we'll do then is we'll substitute this into our equation. 75 equals 25 plus a, and we'll put t in as 0. Now remember, e to the power of 0 is just 1. Anything to the power of 0 is 1, so it's just plus a. So therefore a is equal to 50. So therefore the complete model is theta equals 25 plus 50 e to the minus 0.03 t. Lovely, there we are. That's the answer to part A. Use the model to find the time taken for the tea to cool from 75 degrees to 60 degrees, giving your answer in minutes to one decimal place. Okay, so grabbing the calculator. So 75 was when we started, so we need to find out the time it takes to decrease to 60 degrees. So let's plug in theta equals 60 into our formula. So 60 equals 25 plus 50 e to the minus 0.03 t. Let's first take away 25 onto the other side, so we get 35, and we'll divide through by 50 at the same time. E to the minus 0.03 t. Now we need to get rid of the e, and we do that by learning both sides. So we're going to have minus 0.03 t is equal to ln of 35 over 50 simplifies to 7 over 10. And then we'll times by minus 0.03. So what are we going to get there? Ln of 0.7 times by minus 0.03. That gives us positive 0.010700. No, we divide by 0. Whoops, I've done that wrong. Divide by 0.03, so that gives us instead t equals 11.889168, and now we convert this into minutes and seconds. So that's going to be it's modelled, the temperature is placed on the table, t is minutes, so t is going to be in minutes, so it's 11 minutes and 53 seconds. Rounding that up to the nearest minute, that's going to be what we get, 11.53 minutes. Yeah, so there we are. That's the answer to part B there. Moving on to part C. 2 hours after the cup was placed on the table, the temperature of the tea was measured as 20.3. Using this information, evaluate the model explaining your reasoning. Well, in this case, the model does not work very well. Let me explain why. The model does not work very well. Now, if we look at the equation, theta, which is equal to 25 plus 50 e to the minus 0.03 t. Now remember, e is a value that's always going to be positive. So we're going to have 25 plus 50 times something that's positive, and even if theta is a really super small positive number, then theta at least is always going to be bigger than 25 degrees. So therefore having a recording of 20.3 is not going to be any use to us. So as theta is always going to be more than 25 degrees Celsius, 20.3 degrees Celsius will not be achieved by the model. So the model is flawed. Okay, so there we are. That's the answer to question 3 then. 4 marks for that question in total. Let's move on to question 4.